whenever you have an object subjected to several forces, okay, you can try to reduce your system to one force, okay? If you want to reduce your system to only one force, the condition is that the sum of forces in the two systems should be the same. So here you have several forces, okay? If you want to find a representative force for all, this force should be equal to the summation of these forces. So here I have, this is, let's say this is force 1, F1, this is F2, and this is F3, okay? So you will say that F resultant vector is equal to F1 vector plus F2 vector plus F3 vector, okay? Now, if you have a vectorial equation, if you want to find the resultant force F, what should you do? You can project an X and Y. So you will say that Fr in X is equal to F1X plus F2X plus F3X, and the same for Y direction, okay? So in order to find your resultant force, you should find the components of each of your forces and do their addition. Once you find Frx and Fry, you can calculate the magnitude of your resultant force and the direction of your resultant force. So what is your problem exactly? You don't understand why we do the summation of forces?
And what I'm gonna do with the resultant?
What I am going to do with the resultant, I can say now that I can reduce my system to only one force. So if I put the resultant force here and I add the couple about B, I can say that the two systems will produce the same effect. So because if when I move all these forces to B, what should I do? In order to move them to B without affecting the system, I should add about B the moment of each force. And when I do the summation of the moment, I will end up with one resultant couple. So if you want, my purpose is to replace this whole system by only one force, one couple, which is F resultant, okay, and the resulting moment at B. You can replace your system if you want at any point. So if you don't choose B, if you decide to choose A, what will be the difference? The only difference will be the moment, because the resultant force vector is the same, whatever is the point of interest. So if you move all your forces to A, you have the same forces. So when you do sum of forces, you will get the same resultant Fr. But when you do sum of moment about A, you can get a different couple. This is why you will end up with a different couple here, but you will have the same resultant force. So here you will have Fr, and here you will have M resultant about A. And the whole idea is, instead of dealing with a lot of forces, I can deal with one force only and one couple. Okay? Because they will have the same effect. Since we have seen together that if I move a force from one point to the other, if I add its couple about the point, I will end up with the same effect. This is why we say the systems are equivalent, because I can replace all these forces by one force, one couple. Okay?
And how do we find the force and the couple in the equation?
Okay, from the equations, of course. To find the resultant force, you say first, what is the definition of resultant force? The definition of resultant force is the summation of forces, okay? And since here you have a 2D system, so you can, to find your resultant force, you can first add the x component of all forces, and you find Frx. Add y component of all forces, you get Fry, or here you have a typing error, it's y. Okay, in this way, once you find Frx, Fry, you can find, this is, so if we represent it here, this is Frx and this is Fry. Okay, once you find them, you can calculate the magnitude of your force. The magnitude of your force can be calculated as radical of Frx squared plus Fry squared. You get the magnitude. And in order to know the direction, you can represent it by the angle theta. As we said here, both x and y are negative, so you are in the third quadrant. And to find the direction, you can define this angle, which can be calculated from tangent minus 1 of Fry over Frx. So here, this is just Fry here. Okay? Now, once you obtained your resultant force, we cannot stop here, because when you want to reduce your system, you want to choose a point at which you want to do the reduction. In the given, they told us reduce your system at B. So what is the idea here? If I reduce my system at B, I will move all my forces to point B. But if you move all your forces to point B, in order to ensure that you have equivalent systems, you should add the couple, which is equal to the total moment of all forces in your system about B. This is why we calculated the total resultant moment about point B. We got it's equal to 11,120.6 Newton meter. So you can say that if I take my force to B, I should add the couple equal to 11,120.6 Newton meter. And now, if you want, I can say that this system of force and couple is replacing the three forces I have in the problem. Okay? So I just reduced the three forces that are applied at different points. I reduced them to one force and one couple at one point. This is the whole idea here. So as you can see here, you have three forces applied at different points. I want to represent this system of forces by one force, one moment at B, and this is what I did. Okay? Any other question on this? If you want to, for example, if I tell you reduce at A, what will be the difference? If I tell you reduce your system to point A, for the resultant force, nothing will change, okay? Because Frx will still be equal to sum Fx, and Fry will still be equal to sum Fy. So Fr will remain the same. What will change is the couple, because if I put all my forces at A, and I get F resultant at A, what I should do is, to have equivalent system, I should add the couple of all forces about A. So I should add a couple. Now, it will be clockwise or counterclockwise. I can do the analysis. I should do an analysis to know if it's clockwise or counterclockwise. Okay? Let us assume you supposed it is in the counterclockwise. Okay? And let us verify if it is true or not. What I will do is, I will say sum of moment about A equal to, first, the force of 3,600 Newton will not produce any moment about A because it's passing by A. You still have the 200 Newton force and the 1,600 Newton force. So considering that I choose the counterclockwise as positive, I have the 200 Newton force is trying to rotate about A in the counterclockwise direction. So it's producing a positive moment. It's equal to plus 200 times this distance here, the distance from A to the force, which is equal to 5.5 minus 4 equal to 1.5. Okay? And you have the distance for the second force, which is 1,600. The couple is in the clockwise direction. So it's negative. And it's minus 1,600 times this distance. Okay, this distance is, look, it's not very clear if it's 1.5 or 1.3, but I should take this distance. Okay? So what I will do is, I will do plus 200 times 1.5 and minus 1,600 I think it's 1.3 here times 1.3. If you solve, you will get a negative result. Okay? Since you got a negative result, this means that your moment on A will be clockwise and not counterclockwise. So, or you put here a negative value near your arrow, or you change your arrow, you put it like this, and you put a positive value, because your resulting moment is not counterclockwise, it is clockwise. So you put the clockwise direction and you put the positive value of the moment. Okay, any question? Okay, so we will stop here and we continue next time.